Hey everyone, in this video we'll be diving into the basics of PyTorch, one of the most popular frameworks for deep learning. If you're new to PyTorch, this video will provide a simple introduction to get started. Before we jump in, make sure to subscribe and hit the bell icon for more tutorials. PyTorch is an open source machine learning framework developed by Facebook's AI research lab in 2016. It has quickly gained popularity because of its flexibility and ease of use, making it a go-to tool for researchers and developers working on machine learning models. With PyTorch you can build neural networks, perform automatic differentiation, and handle large-scale tensor complications. Now let's break down how you can start working with PyTorch. First thing you need to do is install PyTorch. Here's how you can do it. Go to the official PyTorch website, select your operating system, package manager, and whether you want to use a CPU or GPU version. PyTorch will generate a code and you simply input it into your command prompt. For example, if you're using Python and pip, you can use this. If you have access to a GPU, make sure to install the GPU compatible version, as it will speed up training significantly. Now that PyTorch is installed, let's move on to one of the most fundamental building blocks, tensors. A tensor is essentially a multidimensional array, similar to NumPy arrays, but with the added benefit that it can run on a GPU for faster computations. Here's a quick example to create a tensor. Tensors can handle operations like addition, multiplication, and reshaping. If you're familiar with NumPy, PyTorch allows you to easily convert between NumPy arrays and tensors using torch.dot from NumPy. This makes transitioning between PyTorch and other libraries a breeze. Once you understand tensors, the next step is to create a neural network using PyTorch's torch.nn module. Let's start with a simple feed-forward neural network. Here's how to define one. To use this model, simply run this code. Always initialize your layers in the init method, and define your forward pass in forward. Use activation functions like torch.reloop to add non-linearity to your models. Once your model is defined, the next step is to train it. Train it involves forward propagation, loss calculation, back propagation, and optimizer steps. Here's how you can train the model. Always remember to use optimizer.zeroGrad before back propagating to clear the previous gradients. This is a common mistake for beginners. Once you've trained the model, it's important to save it for future use. PyTorch makes it easy to save and load models using torch.save and torch.load. Always save the state dict of the model, which includes the model's parameters and weights. This is lightweight and ensures your model can be reused later. Beginners often forget to disable gradient tracking for inference. Use torch.nograd when evaluating your model.
Thanks for watching. If this video was helpful, please like and subscribe to our channel for more tips and tutorials.